So in the last lesson then we connected things up with the on area entered, and we have this invoked from having connected it up inside the Godot IDE. The issue is though, and I'm sure you can remember that from the lesson you've just watched, is that we had to first of all name the function here and connect it up here, and then manually write it into our code rather than having it generated automatically. I've already explained a couple of times, I'm not going to do it again. That's not very helpful in my opinion, it can lead to some errors. So what I'm going to do here is right click and select disconnect. With that disconnected, this is actually no longer going to be invoked. So what I can do is actually press the play to run this, and we should now not see scored inside the output here when the gem collides with the paddle. So let's have a look. I could make this one faster, couldn't I, to make these demos quicker, but we shouldn't see anything in here, and we don't indeed see anything in the output. Good, so I can stop that and close down the output. Now let's do exactly the same thing, but connect it up from inside the code. So back inside VS Code then, what we can do inside the ready is connect this up. So we need to find the area entered signal, and because we are an area 2D or inheriting from an area 2D, we can directly get hold of it. This little lightning symbol here tells you that this is an event or a signal, so in C# it's usually called an event. So I'll double click on that and we have our area entered. Now remember how I told you it's essentially just maintaining a list of addresses or functions that it needs to invoke. We simply need to do plus equals and then add our function to that list. So we're going to add our onAreaEntered function to that list without the brackets. Really important, without the brackets. If you put brackets, it'll invoke the function. We don't want that. What you want is just the function. This is a reference then to where that function is in the memory, and it's been added to this list. So whenever this is then emitted, it'll invoke this function. We'll put a semicolon on there, otherwise it won't like it, and do Control and S to save. Now we've done exactly the same thing as we did in the IDE, it's just now it's really clear inside our code as to where this is coming from and where it's connected up to. We can see it's connected up to the area entered signal or event that is part of the area 2D. Now if I press F5 and actually run the game, we should see then in the output down here the scored again when the gem collides with the paddle. So we're scrolling down the screen to slowly again, my computer's suffering with the spinner there, and we see scored in the output down here. And I think that's a much cleaner way to connect up the signals, and from now on, for the rest of the course, we're going to do it this way. We'll still look at the list of the signals in the IDE so you can see what the signals are. That's actually a little bit easier to get to learn, but we'll connect the signals up from inside the code here because I really think that's much easier to maintain and also to read. Before we end this lesson, there's one more thing we could do just for completeness. At the moment we're just printing scored here. We're not actually scoring or anything, we'll cover that later on, but what we could do is actually get this gem to remove itself from the game when it collides with the paddle. That's really simple. We can invoke a method called queue_free. Now that actually is inherited all the way from node, so open close brackets and put a semicolon. What this does is schedule this node to be removed from the tree at the end of the current frame. So if I do Control and S to save, press F5 to run this again, what should happen now is when the gem collides with the paddle, we should see scored in the output hopefully, and then the gem should disappear and the paddle should be all alone inside the game. So let's watch this happen. Let's slow again, and collision, and there we go, it's disappeared and we get scored inside the output here. How cool is that? So I'll close that down. So we've got one of the main mechanics actually done now inside the game. We've got a reaction to when the gem hits the paddle, which is when we're going to score. What we need to do now is actually alert the game itself that we have scored in some way. Now a really nice way of doing that of course would be also maybe to emit a signal, and then the game can actually connect itself up to that signal, and every time we scored it can increment a score. Unfortunately though, we don't have on any of our nodes that we have at the moment a signal. We do have the signals for the area 2D here, but we don't have any scored signal that something can connect itself up to. Indeed, eventually, when we start playing the game, we're not actually going to have this gem in there at all. We're actually going to spawn the gems in with a timer, therefore no gems even exist. So the game has no way of knowing if a gem has scored or not. So what we need to do is actually create a signal of our own, so a custom signal. Then the game can connect itself up to this custom signal, and the gems can emit this signal whenever there's a score. So we'll take a look at that in the next lesson. So in this lesson we're going to create a custom signal. We have all of these signals already built into the existing nodes, so what we can also do is make our own signal. To do that we're going to have to drop into the code. And when you first start dealing with signals, or what's known as events inside C#, it can actually be quite a difficult concept to get your head around. You end up using something called an event and something that's known as a delegate. The good news is that Godot makes this relatively straightforward and does a lot of the heavy lifting for us behind the scenes. What we need to do is just make sure that we use a certain syntax to make sure that it's able to recognize the signals that we want to make. So what we're going to do is we're going to make our own custom signal that's called onScored. We're then going to emit this signal whenever we score. So what we're eventually going to do is emit our signal from inside here. So to make a signal we need to use an attribute, and that attribute is called signal. Then what we need to do is we need to declare a public delegate, and that's going to have a return type of void. Then what we do is we name our signal. In this case it's going to be onScored. This is the signal that we're going to emit whenever we score a point. This is exactly the same kind of signal as say onAreaEntered down here, which is part of the area 2D. We're not complete there yet though, because for Godot to be able to pick this up, and this is really important, we have to suffix our signal names with event handler. When Godot processes this script it's going to look for the signal attribute, and it knows then that we have an unscored signal that we want to create. Behind the scenes it's actually going to create a signal name class, and we can use that class then to get hold of our signal name. You'll see us use that in a moment when we emit the signal. We still have some red here though, because we need to finish this with parentheses and then a semicolon. Now we have empty parentheses here because we are sending nothing with our signal. But you'll see later on in the course that we're actually going to send information with certain signals that we emit. That might be a score, or lives, or even an entire scene. In our case though, we leave this empty because we have nothing that we want to send with the signal when we emit it. So what we can do there is do Control and S to save. When we do that, we can flick back to the Godot IDE, and I'm going to select the gem scene here, and then I'm just going to rebuild the project. And when we rebuild the project, you can see now we've got our custom signal onScored with empty parentheses here because we don't send any information with it. The area entered signal, for example, here was sending the area 2D, so the other area that had collided with it as information. As is empty because we're not sending anything with it. But crucially, what we're able to do now is connect things up to this signal. So for example, if I go over to the game here and select the gem here particularly, we could then double click on this and connect maybe something inside the game script up to the onScored of this particular. Gem. Now we're not good. Do that here because we're going to delete this eventually and actually spawn our gems into the game. Before we do that though, we should emit the signal. So let's drop back into the code. So the way we emit the signal is really straightforward. Let's just go down into where we've scored here, and we need to do this before we queue free, otherwise we won't have anything. the signal from. Then we simply type emit signal, and then we can open some brackets. And now we can make use of this signal name class. This is a class that's created behind the scenes by Godot, and it will contain a list of all the signals we have available inside this particular object here, which is our gem. And then we can do dot, and we should be able to find here the on-scored. We finish that off then with a semicolon, and that's all we need to do to emit the signal. Now, anything that is connected up to this signal will then receive this and can do whatever it needs to do. We'll do Control-S to save just to make sure we've saved that. Now, if we run this code as is, nothing's actually going to change. What we're going to do is we're going to get scored in the output. Going to Q3, so we're going to remove this from the scene. We're going to emit the signal, but there's nothing connected up to the signal to react to it, therefore we're not actually going to see anything going on inside the game. So it would be nice if we could connect up to this signal, react to it, and actually see something maybe in the output. Going back to the Godot IDE, if we select the game here, you might remember we have the gem here, and that has the on-scored signal. So that brings me to a challenge for you, and this is a little bit of a tricky one. For this challenge, I'd like you to use the Godot IDE to actually connect up to the on-scored signal, much as we originally did with the area entered with the gem. So I'd like you to connect the on-scored signal of this gem that exists in the game scene. I'd like you to connect to that into the game script, and then inside the function that's invoked, we could then double click on this and connect maybe something inside the game script up to the on-scored of this particular gem. Now we're not going to do that here because we're going to delete this eventually and actually spawn our gems into the game. Before we do that though, we should emit the signal, so let's drop back into the code. So the way we emit the signal is really straightforward. Let's just go down into where we've scored here, and we need to do this before we Q3, otherwise we won't have anything to emit the signal from. And then we simply type emit signal, and then we can open some brackets. And now we can make use of this signal name class. This is a class that's created behind the scenes by Godot, and it will contain a list of all the signals we have available inside this particular object here, which is our gem. And then we can do dot, and we should be able to find here the on-scored. We finish that off then with a semicolon, and that's all we need to do to emit the signal. Now, anything that is connected up to this signal will then receive this and can do whatever it needs to do. So we'll do Control-S to save just to make sure we've saved that. Now if we run this code as is, nothing's actually going to change. What we're going to do is we're going to get scored in the output. We're going to Q3, so we're going to remove this from the scene. We're going to emit the signal, but there's nothing connected up to this signal to react to it, therefore we're not actually going to see anything going on inside the game. So it would be nice if we could connect up to this signal, react to it, and actually see something maybe in the output. Going back to the Godot IDE, if we select the game here, you might remember we have the gem here, and that has the on-scored signal. So that brings me to a challenge for you, and this is a little bit of a tricky one. For this challenge, I'd like you to use the Godot IDE to actually connect up to the on-scored signal, much as we originally did with the area entered with the gem. So I'd like you to connect the on-scored signal of this gem that exists in the game scene. I'd like you to connect to that into the game script. And then inside the function that's invoked when that signal is emitted, just print something to the output as we're already doing. Maybe you can do event received or something like this. The Godot IDE to actually connect up here. You might remember we have the gem here, and that has the on-scored signal. So that brings me to a challenge for you, and this is a little bit of a tricky one. For this challenge, I'd like you to use the Godot IDE to actually connect up to the on-scored signal, much as we originally did with the area entered with the gem. So I'd like you to connect the on-scored signal of this gem that exists in the game scene. I'd like you to connect to that into the game script. And then inside the function that's invoked when that signal is emitted, just print something to the output as we're already doing. Up to the signal, react to it, and actually see something maybe in the output. Going back to the Godot IDE, if we select the game here, you might remember we have the gem here, and that has the on-scored signal. So that brings me to a challenge for you, and this is a little bit of a tricky one. For this challenge, I'd like you to use the Godot IDE to actually connect up to the on-scored signal, much as we originally did with the area entered with the gem. So I'd like you to connect the on-scored signal of this gem that exists in the game scene. I'd like you to connect to that into the game script. And then inside the function that's invoked when that signal's emitted, just print something to the output as we're already doing. Maybe you can do event received or something like this. Now if you're scratching your head at this one, don't worry, this is complicated stuff. Setting up signals is complicated, but it's really worth having a go at it because signals are going to be a fundamental part of all of the games that we're going to develop throughout the course. So have a go at that one, and then in the next lesson we can go through it together. With the gem. And that has the on-scored signal. So that brings me to a challenge for you, and this is a little bit of a tricky one. For this challenge, I'd like you to use the Godot IDE to actually connect up to the on-scored signal, much as we originally did with the area entered with the gem. So I'd like you to connect the on-scored signal of this gem that exists in the game scene. I'd like you to connect to that into the game script. and then inside the function. Okay then, so how did you find that challenge? I imagine quite difficult. Even if you've coded before, if you're brand new to Godot, that is fairly tough. If you've never coded before, I imagine it was really tough. But it's okay if you didn't manage to do it, because we're going to go through it together, and I really just want you to get some practice. It's always good to try doing things yourself, even if it's really, really difficult. If you did manage to do it, massive pat on the back. So we'll start off by going to the Godot IDE. In the IDE then, what I'm going to do is I'm going to select the onscored here, and I'm going to double click and I get the dialog. Sometimes I don't with the newer version, so if you don't, the other thing you can do is right click on it and click connect. So here in the dialog we get what we had originally, this warning that the code won't be generated, so we have to add the function manually. We'll do this, and then of course we'll do everything from inside the code. Anyway, I wanted to do this for a bit of practice. Manually, we'll do that. We had originally this warning that the code won't be generated, so we have to add the function manually. We'll do this, and then of course we'll do everything from inside the code. Anyway, I wanted to do this for a bit of practice. So let's change the name here, and we can change the name then to onscored. And now we can hit connect. So in theory we're connected, but we know we're actually not connected. If this was GD script we would be, but we're using C#, so we're not. So we actually have to put this function inside our code manually. Before doing anything else there though, I am going to go Control and S to save, to make sure behind the scenes Godot has just saved what we've done. So let's dive now into VS Code. So the first thing we need to do in VS Code is actually have a look at the signature of the actual signal itself. So it's a void, so that's a return type of void. If you don't know what that is, don't worry, we'll go through C# in a bit. But we have a void here, means returning nothing, and we have onscored, and we have no arguments or anything here. It's important to know the format of this, because we need to make sure that the function that we're about to write that receives this signal is this format that's specified here. So what we could do then is go into game, because that's where we're going to be connecting up, and then we can make ourselves a new function here. So we're going to make a new function called private void, and then we can give this the name that we gave this inside the Godot IDE. So that's private void onscored. We can open and close some empty parentheses, because that's the signature of the event, and that will now be connected up to the signal behind the scenes by Godot, because we did that inside the interface. We can make sure this is okay by doing gd dot, and then we'll do print, open this, and we'll say, what should I do here? I'll say onscored, and then we can say received, can't we? At the end of here then we can put a semicolon and do Control and S to save. Just to recap once more before we go and run this and check it, inside the gem we've made our own custom signal here. The signal has to have this structure here. You will always have signal public delegate void, then you'll have the name of your signal, and then you're going to have event handler on the end. Godot will be looking for this when it actually builds the program, and it'll understand that this is the name of the signal that we actually have. Then if you have any data that you want to send, it'll go inside these parentheses, otherwise they'll just be empty, and we have the semicolon. Behind the scenes then, Godot is creating something called a signal name class, which actually going to put some properties on there, and those properties are the names of the signals. What we do then is we emit the signal when we want to by invoking emit signal, which is part of object, and then we can send in the name of the signal that we want to emit, and magically behind the scenes Godot has actually connected all of this up for us, such that it's actually broadcasting an event as it's known in C# or a signal as it's known inside Godot. Then what we did was we connected up to, or subscribed to, this signal when it's emitted. We subscribe to the signal that's emitted by this specific gem here that's part of our game scene. We told Godot that we want the subscriber of this to be the game here. So we're going to invoke some code when that signal is emitted, and that code is going to be inside this script. We also told Godot that the function that's going to be invoked when the signal is emitted is going to be called onscored. So we then went into the game.cs and we created our onscored with the correct signature or format of the function. It's a void return and there's no parameters, and it's called onscored. And hopefully Godot is going to connect that up for us, because we did it in the interface, and we should see this printed to the screen when the gem hits the paddle. So let's drop back into the interface. Before doing anything else, I'm just going to click build. With the project built, let's actually run it then and see if we can actually see something inside the output, and hopefully we do. So the gem falling down the screen, I'm now waiting with bated breath, and we see scored and onscored received. Brilliant. So not only now are we detecting the collisions using the signal, but we can clearly see that we must have emitted the signal and we must have connected to it, because this onscored received has come actually from our game. It's got nothing to do with the gem at all. it's connected up to this particular signal from this particular gem, and then it's received it when it's emitted, and then it's invoked the onScored function, which has printed the onScored received to the output. So if you managed that challenge, really, really well done. If you didn't manage that challenge, don't worry, plenty of practice is coming with signals, and it is quite an advanced topic, but I wanted you to see it early on because it's absolutely fundamental to Godot. Now you'll quite rightly be saying, hang on, you told us you didn't want to connect signals up this way in the IDE, and indeed, absolutely correct. I don't want to connect signals up this way, but I did want to do this for some practice. What we're going to do now is we're going to connect it up actually from inside the code. Now the reason we haven't done that straight away and we did this is because if I drop back into the code and we look at where we've already done it from inside code, I think that was in the gem here, we subscribe to the area entered signal by adding our on area entered, but this signal already exists as part of our gem class here because it inherits from area 2D. If we go into game, it doesn't actually have anything that it can connect up to. It doesn't have the gem available here in any way to connect itself up to the signal. So the only way we could do that at the time was actually to do it via the interface. But we can of course do it inside the code, but to do that we actually need to get access to the gem that's actually part of the game scene, and in here at the moment we don't have any access to that node. So in the next lesson we're going to have a look at how you can get access to nodes that are part of your scene. In this lesson then, we're going to connect ourselves up to the signal from our gem that's in our game scene, but via the code. To do that we need to get access to our node that's inside our scene. Going back into the IDE, we're actually trying to get access to this gem here, which is part of our game scene. To do that we use a function called getNode, which exists as part of node. We know that game is node2D, and if we look down the inheritance we can see that it does inherit from node, and that has a function amongst many others called getNode. So we'll use this to grab hold of the gem. The thing we have to take note of is the name here, because we're going to actually type out the name of this inside the code. So let's drop back into VS Code, and inside here, inside the ready, when we know that everything is ready, is we're going to get hold of our gem. So we're going to make a new variable here, that's going to be a gem. I'll call that actually gem, nice suggestion there, and set that equal to, and then we want to invoke the function getNode. Now all we have to do here is specify what the type is that we're getting, which is a gem. And then in some brackets here, what we do is put the actual name that we have exactly the same spelling as it is inside the tree in the scene. If you use a different spelling, it's not going to find it. So we can put a semicolon on the end there. Now that we have our gem, we can hook ourselves up to the signal. So we can say gem dot, and then find the onScored, plus equals, and then here what we want is our onScored, semicolon, and Control and S to save. So we're getting hold of the node inside the tree here, and then we're subscribing to the onScored event here by adding our function, which is also called onScored, to the list. Now before we do anything else there, we don't need to name this the same as this. By convention I tend to, so I know what they are, otherwise we get lost, but we could have just called this, for example, stuff, and it would still work if I called this stuff as well, so long as the signature is correct, so the void return type and the empty parenthesis, because that's what the signal is defined as long as all that's the same, it doesn't matter what you actually call it, as long as it's a legal name. However, I prefer to usually call them the same as the event, otherwise I get a little bit lost, so I'll do Control and S to save. We're not complete yet though, because we do need to disconnect the original signal, so let's drop back into the IDE. And inside the IDE I'm going to select the gem here and just go to node and select here, right click and disconnect. so that's no longer connected. Now I'll do Control S to save. I'm pretty sure there was a yellow warning about some building. It's no longer there, but I'm going to build the project. Now what should happen with a bit of luck is if we run the project, we should do exactly the same as before. It's just this time we've connected ourselves up to the signal from inside the code. So if I do this, hopefully inside the output we're going to see, and we do, we see the on score received. Except now what we do is just this would happen, I'm pretty sure, click and disconnect, so that's no longer connected. Now do Control S to save. I'm pretty sure there was a yellow warning about some building. It's no longer there, but I'm going to build the project. Now what should happen with a bit of luck is if we run the project, we should do exactly the same as before. It's just this time we've connected ourselves up to the signal from inside the code. So if I do this, hopefully inside the output we're going to see, and we do, we see the on score received. Except now we've connected ourselves up from inside the code, which I find a lot cleaner than using the interface. So let's close that down, and we can also close down the output as well. Now when we did that, there might have been something that made you a little bit uncomfortable inside the code when we actually grabbed hold of the gem here. If I go back into VS Code, when we wrote this code here, we hard-coded the name gem in here. We spelled it exactly the same as we wrote it inside the IDE. Now this is okay for a tiny example like this, but let's say you're grabbing hold of a few nodes and you've got some complicated scenes, and all of a sudden you decide to change the name of the node inside one of your trees in the IDE, well, your code is going to break because it's not going to find anything. So there is a much better way of doing this, and the better way to do this involves a tiny bit more work for us, but it's going to eliminate the possibility, or almost certainty, of making errors with all this horrible hard-coded strings all over the place inside the code. So what we're going to do is we're going to actually export a property here. We're going to make this a private exported property. It's going to be of type gem, and we'll have the underscore gem to note what it is. Then what we're going to do is we're going to remove this line from here. Actually no, you can maybe want to keep it, so I'll comment it out. And we're also going to put this underscore gem here like this. This is just the naming convention for our private variable here, and do Control S to save. Let's now drop back into the good old interface, then build the project. And with the project built, let's select game, and you'll see now that we've got an assign here with our gem here. It's our new property that we're exporting. What we can do now is we can drag and drop this to here, and that will now be set up for us inside the code to be able to use. So if I do Control and S to save, what we can do now is we can actually run the game, and we should find that things are exactly the same as before. That means it's found the gem, connected up to the signal, and then we're going to see the result in the output. And there we see on score received. So I'll close that down, close down the output. The advantage of doing things like this is, one, we don't have the hard-coded name inside our code, and if we ever change it inside here, so I change it for example to gem2, and then go back to game here, it's going to automatically update it for us. That means if we move things around inside our scenes or anything, the references are maintained. That reduces hugely the chances of breaking our code versus hard coding the string names. I'm emphasising this because I know from experience, a lot of examples tend to grab hold of the nodes doing this and hard coding the strings, but I promise you it's a bad idea to do it like this, because you will get some problems at some point. Much better, in my opinion anyway, is to do something like this. Whilst we're on the subject, there is another way of doing this as well, which is also quite common, although less common than the way that we've seen here. I do want to demonstrate it to you though, so I'm going to comment this out. Another way is to export a node path. So a node path is literally a string path to a node inside a tree. So in our game tree, our path will be game / and then gem for the gem, for example. So our path, I'll just do a comment here just to show you, inside our scene is game and then gem is the path to the gem, for example. With that exported, what we'll do is we'll actually assign that inside the interface, and that will be then this path here. What we can then do is actually make ourselves a private variable inside our class, setting this up, so we'll say private gem and gem. And then what we do inside here, actually I'll just take this here like this, is we do this, except I'll take the gem. So we set this gem here then to be equal to getNode of type gem. Instead of using the hard-coded string that's here, we actually take the path from here like this. and I'll do Control and S to save. Let's go back into the Godot IDE, hit the build, and having built it, you can see now that we've lost our original gem and we've now got this gem path, and it's expecting a node path. If we now drag and drop our gem 2 onto here, it's now actually assigned our node path to this. It's taken the path of this node for the current scene. So if I do Control and S to save and drop back into VS Code, I do notice I've made a slight error here. The path isn't game, it's literally just gem. If we had a child of gem, then say a sprite, then that would be gem/sprite. We don't need the game in the path at all. My apologies for that. So the path is actually gem in this case because we're just at one level. But we've now assigned this node path. What happens then, this path is then used to get hold of the node here. So if we run the game, and I'll actually press F5 and do it from inside here, we should then see exactly the same output that we've seen before. So just wait for it to fall, and we see the same output. So everything's working as it did before, we're just getting hold of the node this way. Now you will ask yourself the question, and I did as well, why would you do this with this extra line instead of just doing what we did here immediately? There is a subtle difference between the two of these. This one here at the moment doesn't have a specific type. If I go back into the IDE, we're setting this up simply as the path to that particular node. Now, it may be that later on you want to change what the type of this particular node is. In this case it's actually a scene, so we probably won't be doing that. But let's say you had a reference to a sprite and then you wanted to change the type of this node. So this at the moment is a sprite. If I go right click, I can actually change the type to any of the nodes in the list here. We're not going to because we need it to be a sprite. If we did change the type, we would have a problem inside here. If we were assigning that to a specific type, that would break because say it might be expecting a sprite 2D and it's now getting say an area 2D instead. If we're using a node path, it doesn't matter about the type, we're simply getting the node path. That doesn't really solve any problems inside our script though, because we still have the types here. Therefore if we do change the type in our script, we do have to change this type. However, if you're just using the node paths, then this is another way of doing things. We're not going to be doing this at all, I don't think, during the course, but for you to have that, I'm going to comment that out, then uncomment that so we have this here, and then actually comment this line out as well, because we're not going to need it. Then what we can do is we can go back inside here, and I'm just trying to squint here and remember what I've done, yet we can also comment this out as well, and we're back to where we were before. So Control S to save there, back to the IDE, and inside the IDE then we can build, and we should have then our empty slot back inside the inspector here. So we do, and I can drag and drop the gem, and we're now back to where we were before. So we've seen now how to connect up to custom signals, and we've also seen now how to actually get access to nodes that are inside a particular tree. However, we're not going to be working with one gem in the game. What we're actually going to be doing is spawning gems into the game. Then we'll connect up for each of those to the scored signal so we get the score, and then also later on we'll have a game over signal and things like that. So to get all of that up and running, we actually need some gems in the game. So the next lesson, what we can do is actually start spawning these gems into the game and get a bit more action.